So in this video, we're going to talk about the hydrolysis of imines. And just like how we talked about the hydrolysis of, acetals. So what do I mean? Well, if I see this molecule in solution, okay, and I hydrolyze it. So if I throw this in acid, well, it looks to me as if I'm going to get a ketone plus, what is that, ethanol. Okay, so it looks as if to me I'm going to get this. So I'm hydrolyzing it. Okay, well, the same thing is true for imines. So it looks to me as if this molecule is thrown in solution with acid, it will just go. And it looks to me as if I'm going to get that ketone back, plus I'm going to get ethylamine. Okay, now we want to know, how does this work? What is mechanism? How can we predict a mechanism for what's really going on here? And you kind of see the similarities, to be honest with you, with these types of chemistry. Okay, well, let's go through the mechanism for the imine. Okay, so sorry about that. So like with carbonyls, okay, if I throw an imine in acid, the first thing it's going to do, these nitrogen has two lone pairs on it. So the first thing that's going to happen is that it's going to search for hydrogen. It needs protonation. Okay, and so we'll get a nitrogen, okay, with 4 bonds. Okay, dope. It has a plus charge. Okay, now we just formed water in solution. Okay, we just formed water in solution. And so water, we know, is an excellent, oxygen is an excellent nucleophile. So it's going to come in and attack the carbon that's containing that nitrogen oxygen double bond, that nitrogen carbon double bond. Okay, and these electrons are going to flow back on the oxygen in the form of lone pairs. And so we get to an intermediate that looks like this. We have our nitrogen. Okay, it's now neutral. These two lone pairs on it, 3 bonds, it's neutral. Okay, and we have water that now has a plus charge. Okay, now what ends up happening? Well, remember, we have water in solution, and so it's going to act as a base. Okay, so it's going to come in and grab these hydrogens and reform acid in solution. Okay, and we come to an intermediate that looks like this. Okay, we have our hydrogen, okay, and we have an alcohol. Okay, so we come to an intermediate that looks like this. Now, what will happen in a second? What will happen after this? Well, again, we just reform acid. And so what's going to end up happening? NH plus, H3O plus, okay? So what is going to end up happening? These lone pairs of nitrogen will come in and search for hydrogen and form water back in solution. Okay, and once we do that, we come to an intermediate that looks like this. We have our OH, and then we have a nitrogen that has 2 hydrogens. Okay, nitrogen, 4 bonds, automatic plus charge. Now, the last step of the mechanism, the bond between the oxygen and the hydrogen will come in, form a double bond, and expel ethylamine. And so we find the products to be acetone plus N2H or NH2, ethylamine. Okay, so we just hydrolyze it. Now, let me give you a very important tip, okay, with nitrogen chemistry and these ketones and aldehydes, okay? Anytime I have a ketone or aldehyde and I have, say for example, NH3, okay? The general procedure is that I'm going to keep my double bond. I'm going to replace the nitrogen, the oxygen with the nitrogen and lose 2 hydrogens. That is a general procedure. So I could predict the product. I'm going to keep my double bond. I'm going to get my nitrogen. I'm going to lose 2 hydrogens. So this has to be NH. Okay. Now what about the same? I'm going to show you a pattern here. Okay. So I take this molecule and I add ethylamine, NH2, well, it's reasonable. I'm going to lose my 2 hydrogens. I'm going to keep my double bond. I'm going to replace the oxygen with nitrogen. I just redraw the structure. So I come to something that looks like this. I lose 2 hydrogens. That means this has to be N, and it's bonded to this. So that's the product. Now, this is only when you're able to lose 2 hydrogens. So this is only with ammonia and any NH2 molecule. When it comes to NH, we got to be very careful, and we'll talk about that in the next video. Because in fact, if I take cyclohexanone, okay, if I take cyclohexanone and I add, let's see, if I add, let's see, if I add trimethylamine, okay, so if I add trimethylamine, well, the let's put dimethylamine, okay. So dimethylamine, let me redraw the structure. It looks something like this. It has 2 CHs, 2 CH3s, okay. So this is our structure. Notice that now I only have 1 hydrogen in excess, okay? And so I won't lose, the reaction pattern won't be like this anymore since I can't lose 2 hydrogens. And so the product for this will actually look something like this, okay? I'm gonna have a single bond to the nitrogen with the 2 CH3s. I'm gonna have a double bond. Yeah, so this is a CH3, okay? I'm gonna have a double bond adjacent to the nitrogen. So these are the patterns, these are the 3 patterns that we should look for when we talk about ketones and aldehydes and nitrogenous chemistry, okay, with imines and etc. Okay, so in fact, this is called an enamine, but we're gonna worry about that in the next video. But I just wanted to show you the 3 patterns. So whenever you cannot lose 2 hydrogens from the nitrogen, you're gonna form a double bond, you're gonna get a single bond to the nitrogen and whatever is bonded to that nitrogen, okay?